Hello everyone, my name is Wesley and I'm going to do this very simple limiting reactant problem today. So when we look at this problem, here's our reaction. It's already balanced for us. Here's our problem. Determine the limiting reactant when 0.10 moles of each reactant is present. Also, predict the number of moles of excess reactant. So for this problem, we have to determine the limiting reactant first before we can find out how much excess reactant we will have. To determine the limiting reactant, we need to convert the number of moles of each reactant to a product. And in this problem, I'm going to pick this as our product because there's only one coefficient in front of that product. So the stoichiometric coefficient is much easier to work with, rather than 1 is easier to work with than 6. So we're going to start with this reactant first. So for that reactant, we have 0.10 moles of that reactant. And when we look at the coefficients here for that reactant, we have to make one product, 1 mole of that, 1 mole of product, it is 3 moles of the reactant. So for every 1 mole of product, we have 3 moles of reactant. And when we calculate this, we get 0.033 repeating moles of product. So for our other reactant, we have the same amount of moles because of our problem, and when we look at the coefficients here, for every 1 mole of product, we have 2 moles of reactant. 1 mole product, we have 2 moles reactant. When we do this calculation, we get 0.05 moles of product. So when we have these two yields here, how many moles of product that we can make, we can only make the smaller amount because we'll run out of that product faster, which makes it the limiting reactant. So when we look at this, we see that this value is smaller than this value. So that makes this reactant the limiting reactant. And that makes this one the excess reactant. So now that we know both of these, this is the actual amount of moles of product that we could produce in this reaction. So there will be an excess in our excess reactant. So to determine the moles of excess reactant, we take this theoretical yield here, which isn't possible to produce in this reaction, this number of moles, by our actual number of moles that we will actually get out of the product. We will subtract that from this theoretical value. And we get this as our value, 0.0166. this is our sig fig. But this isn't what is that it's asking. It is asking how much moles of excess reactant. Right now we only have the moles of the product. To get to the moles of the excess reactant, we need to go back how we came through. So we're going to take this number, because this is the theoretical number here, and this is the product still. We're going to look at the coefficients again. So for every 2 moles of the reactant, we have 1 mole of product. To cancel it out, we have 1 mole of product. Mole. For every 2 moles of the reactant. And when we do this, we get 0.033, and that is to the right sig figs there. So that is how much reactant we will have left of the excess reactant. So the excess, and that is how many moles of excess reactant we will have left. And we will have 0 moles of the limiting reactant left.